So the question today is, Charlie, how come everyone hates calculus? I don't know. Maybe because of the chain rule. Before I start bashing the chain rule, let me tell you that it's probably the best, most powerful tool for differentiation in calculus. It's actually not horrible to use. It's not horrible to use at all. You get into a kind of a rhythm of it, but the reading of it and the description of it will drive a person to sheer madness. So it says here, the chain rule by definition, if y equals f of u is a differentiable function of u, and u, this u, is equal to g of x, is a differentiable function of x, then y equals f of g of x. Well, of course it does, because if u equals g of x, then this really says f of u, doesn't it? Is a differentiable function of x. And this is where it starts to get slippery. Then dy dx, the derivative of y with respect to x, is dy du times du dx. What? Or, and this is the form that we're going to use most often, the derivative of f of g of x, a composite function. And when I show you a couple examples, if you're still with me, we're a minute into this, if you're still with me, it's good news for us, because this is going to make sense. It just looks like hell right now, and I'm really sorry about it. But the derivative of this thing is f prime at g of x times g prime at x. Look at this for a second. Think of this kind of like a composite function. So here's this composite function right here. We have f of g of x is equal to f of u. And I'm trying to convince you of this, that we're going to break this into pieces, and we're going to look at it like this. This right here, these pieces right here, are the outer functions. Stay with me, please. This is going to make sense in a second. It really is. These are the outer functions, and guess what? These are the inner. This is the inner function. So here's the inner function. Let's see if we can take a look at one and see if it doesn't make some sense. Right now, if you're still with me, first off, you get an award. I don't know. We're going to give you a bronze star or something crazy. I don't know. But let's look at one for a second and see if we can't make some sense of this. So I'm suggesting you this. So to the blind eye, it looks like this. Y is equal to, I don't know, x squared plus 1 quantity to the third power. So now, I'm asking you to look at this in two different ways, as if this was two functions. Let our first function be this one right here. So let our first function be this cubed thing, right? And that's our f of x. And let this function be our second function, our inner function, and let this be a totally different function. And you can see that these functions, that the total function is composite of the two functions, made of both pieces, right? So all we're going to start doing is this. We're going to do a little bit of substitution here. So first thing I always do is I'm going to build a list. Why am I building a list? Because I want pieces. What pieces do I want? I want these pieces. All right? So we're going to start building our list. So here's my list. I'm going to gather my pieces up here. First thing I'm going to do, if you go up to the top, it says u equals g of x. So I'm going to say, let g of x equal u equal, and what I'm going to do is I'm going to take this inside piece of the function out, because, right, the inside function is the g of x. I'm going to take that out, and I'm going to say, let u equal x squared plus 1. Then I'm going to say, what's f of u? Well, f of u is that outside piece, so it is u cubed. See? U cubed. So then, look at this. Now it gets a lot easier now. F prime at u. Now I'm just going to differentiate this piece right here, and that's not too bad, right? I can just use the power rule here, and we get 3u squared, right? I'm also going to need, it says here that I'm going to need my g of x. So I'm going to gather my g of x and say, okay, well, g of x, you know what, let me use the right colors. Here's my g of x right here, isn't it? That's g of x right there, isn't it? So my g of x, I'm just gathering that inside piece of the function, g of x is equal to x squared plus 1. G prime at x is just the derivative of that thing. And the derivative of x squared plus 1, as you know, is 2x, right? Now, we've done all the work here, actually. And all we're going to do now is just take this piece of information right here and fill in the blanks. Fill in the blanks. And this gets really good. So what I'm going to do here, it says that our function, right, again, we're here, aren't we? We're right here, right? We're filling in these blanks right here. So it's we know that f prime, is this thing, so I'm going to take this and say that y prime is equal to 3, that this 3 is this 3 is this 3. I'm going to put my u in here, because it says u, and I'm going to square that. Now, go and find what u is. Well, g of x equals u, so g of x is also equal to this. Pick up this piece and just put it in x squared plus 1. And then it says right here, it's reading from here, I'm just putting the pieces together. It says that g prime at x is this 2x right here. So, times 2x. Believe it or not, you guys, we're done. I can simplify a little bit. Remember, can't distribute into here because we're held up by this exponent, but we can certainly multiply this piece and this piece. So we get y prime is equal to 3 times 2x is 6x, isn't it? Times x squared plus 1 quantity squared. Welcome to calculus, because you don't have to expand this, okay? All right, I hope this is helpful. I'm going to actually do another video just to try to give us more practice with this. But this is really, really doable. What do you need to know? What you need to be able to do is take this idea right here. You need to be able to figure out what the inner and outer functions are. And then you need to be a good list builder. And we're also going to talk on the next video about the skill of rewriting into a form that we can differentiate more easily out of. So, okay, great work.